Hello and welcome to a whole new series of videos I'm going to be producing all about editing on Apple hardware. Today we're going to be focused on the brand new 2019 16-inch MacBook Pro. This is the machine that I do quite a bit of my work on, and today we're going to be looking at how it performs with h264 codec in UHD. Let's first take a look at the hardware itself. This is kind of an upgraded machine. So it is a 2.3 gigahertz 8-core i9. It has 64 gigs of memory, which is the max you can put in it currently. It has a Radeon Pro 5500M 8 gig, and it has the built-in iGPU, which is QuickSync. These are very important things to have when using h264 because without QuickSync, you're going to have a lack in performance, especially on a laptop. Now, let's talk a little bit about the other features of this laptop. It has a 3072 by 1920 display, a 2 terabyte NVMe, which is the best bang for the buck. First thing we're going to do is do a couple benchmarks so we can show you how the machine actually performs benchmark-wise before we actually dive into working with DaVinci Resolve and Premiere Pro. We run TG Fan Pro. And TG Fan Pro allows us to monitor and manage the fan controllers. Before I go any further in this video, we're going to go ahead and turn the fans on to max because we want to eliminate any thermal throttling that might come from using these programs. So we're going to turn the fans on to max, and now we're going to go ahead and start performing a couple of benchmarks so you can see how quick this machine is. First benchmark is going to be the Blackmagic raw speed test. We're going to run it at a 3:1 ratio at 8K, which is the most difficult ratio to run it at. This will give you an idea of how fast this machine is compared to your machine at home. Now, I have noticed this laptop being kind of slow compared to desktops, but it's also pretty fast for a laptop. We are plugged into AC power right now during this test, which means that we are getting the full wattage capable. If you run on battery, you're going to get a little bit of a less score, but it's okay. It's acceptable to run it on battery if you need to for some reason. But today we're plugged in. And as you can see, we can do a complete 8K edit with all Blackmagic raw formats at 30 frames a second, no problem at all. So that's pretty good. Now, of course, it's single layer, but nevertheless, it's possible to do. One thing I want to mention before we move on to the speed disk test is that this machine has only 16 PCI lanes, which means that the GPU is only running at 8x speed. So the test is not as good as it could have been GPU-wise. Now we're going to move on to our speed disk test, which is, of course, just testing our internal drive. And as you can see, the speed disk test is doing pretty good. It's about 2,400 to 2,600 megabytes a second. These machines have a single NVMe running at a link speed of 4x, which is kind of common for NVMe's on most computers, so it's not running slower than it should be running. The difference is that because of the T2 security chip, and because everything that's written to the drive is actually going through an encryption process, the speed of the drive is actually lower than some of the older computers per se, or maybe your PC at home that has an NVMe as well. So that's something to think about when you're looking at these speed tests, is that it's not quite as fast as a normal NVMe could, and that's the reason why. Now we're going to go ahead and use Cinebench. During this test, we're going to show you what our processor temperatures are, because of course this is the critical element. We do not want the thing to overheat. Right now it's running at 51 degrees. Our Radeon Pro is going to be pretty much idle through this whole thing anyway. So let's go ahead and run our Cinebench. Now during this test, we're going to go ahead and open up our activity monitor, and we're going to show you exactly how the machine handles this benchmark. Now, funny enough, one thing that people don't quite understand is that even though it is using the CPU at what looks like 100%, it actually isn't. It's actually using it at about 1500%, which is not all the cores. You'll also notice that there's something in there called kernel task, and it's going to be showing up a lot in our tests here. The kernel task is actually a very important thing that if you see it use up your CPU, what it's doing is thermal throttling the machine. So right now you can see the kernel task is actually doing okay, but in later tests you might see it actually spike a little bit because it's trying to prevent the machine from overheating. So currently we are increasing our temperatures, as you can see. It's going pretty fast. CPU proximity and the core temperatures are all getting up to almost 90 degrees. 90 degrees is pretty much the cutoff, but as you can see, the kernel task is actually not thermal throttling right now. And I think the reason why it's the case is because we're not using all the CPU cores during this test. Again, I don't know quite the reason why it's not. I don't know if it's a function of the machine and how hot it gets, or if it's a issue with the operating system trying to prevent it from using all the cores. But anyway, now we're at 90 degrees Celsius, which is about the point where the machine usually starts to thermal throttle. But we're almost done with our test, and there it is, 3185, which is actually not a very good score for this machine. I've actually gotten 3400 before. The Geekbench score is always nice to have, 1053 on single and 7050 on multi-core. GPU, remember, is an 8X GPU, so it's not really running at full speed, and it's 33400. I'm sure at full 16X it would be a lot faster than that. The reason why I'm using my iPhone to screen grab this is because the screen grabbing software that's built into macOS uses a lot of system resources, and I didn't want to drag down my benchmark and use it. So I apologize for the shaky iPhone with out-of-focusness. That's just what we have to deal with in this video. We are using the brand new version of DaVinci Resolve. It's Studio 16.2.1. We use the Studio version because the Studio version allows hardware h264 and h265 encode on Navi GPUs, which is the GPU we have in this machine. It also allows for our QuickSync to work properly. So today we should see some pretty good QuickSync playback results. Let's go ahead and open up our test product we've already made, of course. And we're going to go ahead and rewind all the way back to the beginning of this project. Again, this project is playing back at full resolution. The render cache is turned off. Let's go over here and show you the GPU settings. Memory and GPU is, yep, so we're set to metal and manual control. We want to make sure it's actually defaulting to metal. And decode options are decode h264, h265 using hardware acceleration. That's the critical element. If you have that checked, then you're good to go, generally speaking. We're going to keep that checked, even though we have found that sometimes the CPU can be a little bit faster at some effects because it's overusing the GPU. In this particular playback sequence, we find that the GPU is doing a really good job, and we're going to leave it alone. We have found only a small difference on this sequence. Not worth running a test with just CPU mode. All right, let's go ahead and move on with this and talk a little bit about our media, because we decided that we're going to be doing h264 UHD media on this project. So let's go ahead and show you our project settings here. And we are at 3840 by 2160 Ultra HD. We don't really using monitoring, but we're going to keep the monitoring to, the same exact thing as the timeline format just in case. And I think that's pretty much everything we really need to see in here. The settings are basically the base settings. Image scale set to smoother. Anti-aliasing is turned to auto. Yeah, there's not much in here we need to look at. And let's take a look at the media so you can see that the media really is 3840 by 2160, which it is, except for one clip at the bottom there, which is 4096 by 2160. And that clip is being scaled a tiny bit, but it's not really a big deal. That's not going to hinder our performance at all. All these files are 100 megabit per second h264s, by the way. All right, so here we go. Let's go ahead and turn our CPU temperature on so we can look at that while we're playing back. As you can see, we're at about 50 degrees Celsius in that range. And that's going to be a good start for us. And we are also going to activate, sorry about that focus issue. We're going to also activate Activity Monitor so we can show you our usage. Now, I have noticed that the machine does play back kind of slow sometimes with Activity Monitor on, but doing many of these tests prior, the performance decrease is so minimal that we're going to run Activity Monitor throughout the entire piece, and you can see through the entire show exactly how it's playing back. So single layer playback, of course, is great. You can see the GPU. It only uses about half of it during these dissolves in single layer mode. Now we're going to get to something a little bit more complex than just single layer. we're going to go to a 50% opacity with a 50% clip on the left and a 25% clip in the top right-hand corner. As you can see, it's all playing back very smoothly. Our next task is going to be, again, one more level of complexity. Basic motion. So basic motion is a critical thing. We want to make sure that it actually will play back basic motion in real time. Notice our GPU hasn't really changed very much at all. It's still using about 3/4 of it. And the iGPU is using a little bit, but not very much. The next section we're going to see is, of course, a 3D movement test of 5 streams. So again, it's a 50% opacity with 3 colored layers, 2 25%ers and 1 50%er. And with this slow move, and we wanted to see how the 3D engine would work. As you can see, it really used a lot more GPU on that one. All right, our next test is 6 streams. So we're going to lay these layers in here, and then we're going to layer on top of them all. And as you can see, everything runs completely, totally smoothly through this entire process. And we didn't use up our entire GPU on that one. The final one, big final test here, is going to be our 10 layer. So we're at 3, 4, 5, 6, 7, and this is about where we end. As you can see, our GPU is almost maxed out, and if we add one more layer, it's basically not going to play back anymore. And this is kind of possible. You can see it kind of chews through it, but that it eventually can't really get through it at all. And that basically ends the DaVinci Resolve test because it can't get past that. So that's basically our first test here. And it worked great up until the last bit. And the reason why it took a little bit of time to work that is because those last layers are duplicates of the layers, the first layers. And so it's hard for it to read back the duplicates. I wanted to see if it could do it at all, and it really can't. Now we're going to go ahead and do an export test. And we're going to do kind of a low quality export test because we don't want to waste our time doing a big file. So I'm going to go ahead and label this test, and we're going to put it on the desktop. And we are going to make sure that it's all hardware acceleration available. It's going to be 10 megabit per second. And that's kind of a good optimal export for h264 UHD. And we're going to go ahead and add this to the render queue. Hold on a second. I got to make sure that this thing has actually got the in and out point set up. Hold on. Yeah, I think it's okay. Hold on, I'm gonna check this really quickly. Make sure this is right. Yeah, it's got everything selected. I was doing other exports earlier. We're gonna start this at 12:23 because we want to start it on an actual time and not just some random number, so we can actually get a real test of how long it took to do this encode instead of trusting the software package to tell us. So as soon as that hits 12:23, we're going to go ahead and hit the start render button. There we go. And it is rendering away. Now this, of course, is going to use all the system resources because it doesn't need to play back in real time. It's going to, the sections that it can play back faster, it's going to play back faster. And sections it's going to play back slower, it's going to play back slower to make sure that it's rendering in the highest quality possible because it doesn't play back at the same quality it renders at. So as you can see, it's hitting the GPU pretty much at the maximum it can. And as you can see, the iGPU, or QuickSync, is being used pretty well, about halfway. Our CPU cores are, of course, going to increase exponentially. Our GPU is going up. It's at 83 degrees Celsius right now. It just keeps on climbing and climbing and climbing. That will eventually probably hit the red zone at one point because we are using pretty much all the GPU, as you can see. The CPU should be pretty cool. Kernel task, as you can see, is worse now than it was during our Cinebench test. So you can kind of see how that is probably hindering our performance a tiny bit with the potential of thermal throttling. It's like, I might thermal throttle, I might not thermal throttle. Kernel task also can mean writing data. I've noticed that if you're copying data, writing data, kernel task does show up. So perhaps the kernel task going up could also mean writing data, which of course we are writing data right now. Our GPU is still sitting there at 88 degrees Celsius at max fan speed. It doesn't seem to want to go higher than that. In fact, we just dropped a little bit, which is pretty good. Some of these difficult renders, as you can see, are taking a little bit of time. The more difficult sections are dropping down to, 10, 15 frames a second. Look at our cores. They're doing pretty good. I mean, 77 degrees Celsius is actually relatively decent. These processors don't like to run over 90 degrees Celsius. So, as long as we're below 90, it's going to do okay. Kernel task just peaked a little bit, just went to 12%, but now it's back down again. So it's moving around, but it's not really affecting our performance really at all. Look at that wall of GPU. That wall of GPU is fantastic to see, the fact that it's using all the GPU, or should I say as much as it can, and that the QuickSync iGPU is actually being used in spurts. If you notice that, it has little peaks in it. I wonder if that's the sections where it actually is playing back all of the h264 at the same time. But as you can see in our 10-way split coming up here, it's really chugging through this. It's really having difficulty doing this. It's dropping in frames. It was 13, it was 12, now it's 11 frames a second. It's really difficult for it to export this exact section. Our kernel task is staying pretty good at around 7% CPU, and our GPU is at around 84%, so it's really not killing the machine to do this, even though it's only rendering at 9.5 frames a second. So that's actually relatively decent if you look at it in the long run. All right, this is almost over. It's at 95%. Just a couple of frames left to do before we can move on to the next test. Again, a little close-up of the kernel task. You can see the DaVinci Resolve is only using 140% of the CPU, which is nothing. And yeah, this is pretty much the end. Couple seconds here, and then we should be done. All right. So it said it completed in 3 minutes and 33 seconds, which I actually trust because DaVinci Resolve is pretty good. It's 1226, so that makes sense. 3.5-minute video encode, that's pretty good. All right, that pretty much ends our DaVinci Resolve test. Now what we're going to do is we're going to go ahead and quit and go to Premiere Pro. We're using the current version of Premiere Pro, which is CS 2020. We have found that CS 2020 is the only one that really works good on Catalina, so it seems to be the best option. And of course, we made a sequence in Premiere Pro that is identical to the DaVinci Resolve project. You will notice some small differences. I accidentally used some of the wrong clips in some of the sections, but it's the same setup and it's the same clips. That's all that really matters. Things on graphics mode. Whoops. Let me go ahead and fix that. Hold on. It's hard to hold the phone and do this at the same time. All right, so let's go to editing and let's go ahead and show you some of the setup here. So we're going to go to product settings and we're going to go to general, and we're going to make sure it's actually doing the GPU acceleration, which of course is the most critical element because that's the way we had DaVinci Resolve set up. I'm going to show you the sequence settings. We have an editing mode of DNxHR UHD, 29.7 frame rate. Very important that we are using our video process at the same exact frame rate. Maximum bit depth and maximum render quality are both selected, which is the way Resolve works. And then over here, we're going to show you that we have high quality playback and we're at full resolution, which is very, very important. So without further ado, let's go ahead and play back the Premiere Project version of our test. Go ahead and launch Activity Monitor first. And let's go ahead and close that. And boom. All right. So as you can see, it plays back single layer, but go ahead and look at that GPU. It's using a lot more GPU than the DaVinci Resolve playback was. That is almost peaking the GPU right at the beginning of the playback. It's also using quite a bit of CPU. And look at QuickSync. It's barely touching the QuickSync, which is really interesting to me. I don't quite understand that at all, why it wouldn't want to use as much QuickSync as possible. Some of these dissolves are stuttery. If you look at the dissolves later on in the show, you'll notice that they get a little bit stuttery. The real-time rendering engine's not quite as good as DaVinci Resolve's. So with our 4 streams, you notice right away that it is stuttery. Look at the jumpiness of it. It cannot play this back smoothly with just the 4 streams. The GPU is completely maxed out. and there's nowhere else for it to go. Sorry about the focus issue. Keep moving the phone back and forward. Look at this. Basic motion 4 streams. It's a little bit smoother than the previous one with the opacity, but still not smooth at all. Playback is really hindered on Premiere, and you can see that it's using quite a bit more CPU than DaVinci Resolve and quite a bit of GPU as well. With 5 streams, as you can see, the playback again is not smooth. It is very jerky. It's not even getting to 2997 frame rate playback. In fact, I would say it's more like 18 or so frames per second playback speed. Now, the big test, the slides. The slides are all stuttery coming down from the top. It's not horrible, but they're all pretty stuttery. And then the last one is, let's see. Oh, man, that thing is really bad. Yeah. And look at it. It can't even play it back. Watch the ocean. See the ocean? Look at the ocean. Look at that. It can't play it back. A single stream there. Can't even play back. So this is smooth. We can get 3 streams up here. Oh, nope. It's already dropped off. You can see it's already dropped off. It's already stuttering. So even with the 6 streams, it's stuttering already. It can't even play back those smoothly. And then, of course, when we add the other layers, it's doing okay when we add the other layers, I've noticed. So yeah, that comes in, and then these other come in, and so it will play the layers back, which DaVinci Resolve would not do, but it does not really play them back. It just stops. It maxed out pretty much everything it can max out, and that is pretty much the end of that. It can't really do more than that, unfortunately. I don't quite know the reason why it can't, but it really can't. All right, I'm going to make a small adjustment here because I noticed that these go a little bit longer than the DaVinci Resolve output. We want to make sure that this export is the same. So let me just fix that really quickly. And then let's go ahead and make sure we're all selected here. And yeah, I think we're good. Oh, I want to show you one more thing, which is that when you scrub, it doesn't refresh very fast at all when you scrub in Premiere. Now, I'm not saying DaVinci Resolve does this good at all, because it really doesn't do this good either. But with Premiere, it's really egregious, I've noticed. It's doing okay right now because I think it's cached it a little bit. We have such a fast hard drive that I think it's caching and then reading the cache files because it's played the whole thing back. But I've noticed in the past that it doesn't do very good at that at all. It really has trouble scrubbing through, but as you can see, it's scrubbing through now fine. So make an idiot out of me, I guess. But when we first made the sequence, it wouldn't scrub through at all. Not even in the slightest. It would just sit there. So I guess playing it back really helped. All right, now we're going to go ahead and go to Export Media, and we're going to go ahead and select our h264 encode. Very, very important to make sure that hardware encoding is turned on in encoder settings. Can't really do a test without that. And we're going to use the same exact bitrate, variable bitrate 1 pass, 10 megabits a second. That's kind of the most critical thing. I want to show you something though. When you adjust the bitrate, you'll notice that the hardware encoding stays on. But if you put it to constant bitrate, you'll notice the hardware encoding actually turns off and goes to software encoding only, and you can't turn hardware encoding back on again. I thought that was really interesting because constant bitrate is actually kind of a good thing in some ways. So the fact you can't do hardware encoding with constant bitrate is interesting. I don't know if DaVinci Resolve can adjust that though. I think it might only be variable bitrate. Not quite sure. Okay, that's the only real setting. We're doing, again, 10 megabits per second, and we are going to be using maximum render quality. As you can see, that's selected. I think, let me go ahead and make the name of this thing, put it on the desktop. That's fine. And boom, let's do it. Oh, right, we can't do it until we get the time. We got to get the time. So what time is it? It is 12:33. Let's do it at 12:34. That'll give us an understanding of how much time it actually took. I don't really have a stopwatch handy because my computer's busy and my iPhone's busy recording this video. So not doing too good. There we go. Hit it. It is encoding. All right. 2 minutes. I would say it said 2:30 to start with. So let's just say it's going to take 2:30 because that's what it said to start with. And as you can see, it is using... Hold on a second. Let me get the activity monitor up and the fan controllers up. Hold on. I want to see what it's doing for activity monitor. Yeah, the GPU is being used quite a bit, but look at the QuickSync. It's hammering QuickSync. It's doing exactly what it should do, exactly what Resolve did. But look at the GPU. It's really not completely hammering the GPU. Remember, in DaVinci Resolve, the GPU was just a wall of GPU, but in Premiere, it's really not hammering it. I think that possibly could be because it's using more QuickSync. Oh, look at the CPUs. What the heck? What is that doing? Wow. Wow, look, it just maxed out my CPU. That must have been that little transition I put in there, and it can't render the transition on the GPU. And look at the GPU, it went to nothing. Wow, that's interesting. I just put a little box wipe on Premiere. I should have put it on Resolve, and I didn't by accident. I just wanted to see what it would do, the box wipe. That must have been the box wipe, the box transition, because that would probably cause that, the fact that it would use the CPUs. But that was interesting. Just that little transition would do something like that. It's really interesting. I really want to see activity monitor brought up, but hold on a second. I'm just looking at our CPU again, and I guess it's kind of using the GPU. I guess the GPU is kind of being used, but man, it is just not hammering it like Resolve was. It looks like it's using the system resources entirely different than Resolve. It's really interesting how it's dealing with this. So CPU temperatures are okay. GPU temperatures okay. About what it was doing with Resolve. The numbers seem about the same. Even though we had that hit earlier. But now the CPU is back being used again. Oh, look at that. Wow. CPU is back being used again, and it's creeping up in temperature pretty fast. Yeah, because Resolve didn't use the CPU very much at all. So we're almost at 80 degrees Celsius. Yeah, it's just kind of hovering at the high 70s right there. And the Radeon Pro is at 82 degrees Celsius, so that's pretty good, I guess. It's again, it's below 90, then it's okay. Wow, interesting. Very, very interesting. It says 52 seconds remaining, but I have a feeling we're not going to get that because obviously we haven't hit the worst section of it yet. So we're at 12:37 right now, so we started at 12:34. So we're basically 4 minutes in, or close to 4 minutes in. Yeah, so we're at 89 degrees Celsius on the GPU, and it's finally using it. But look at it, the little peaks in it. It's so strange. Yep, there it goes, 90 degrees Celsius on the Radeon Pro. We just hit it just for a brief second there. And that's really interesting that I would hit that at all. Wow. So it's really hitting the GPU in a very different way. Hold on one second. Let me bring up Activity Monitor, and let's look at the kernel task to see where that's sitting at. So the kernel task is at 9%, which is no different than what it was on DaVinci Resolve, really. So that's good. So it's not thermal throttling the machine quite yet. And it shouldn't at 78 degrees Celsius. It really shouldn't be thermal throttling the machine at all. So this is actually relatively good. 30 seconds remaining. This is, of course, the hardest part of the video, so I don't know if it's going to take 30 seconds to finish this, but it's kind of nice to see this in real time. It's 12:38, almost 12:39, so we're well over 4 minutes. Let's see, it's about to go to 12:39 in a second now. So let's see here, 81 degrees Celsius on the GPU. Oh, the GPU is now backing off entirely. So the end of the video, it is not going to use the GPU on for some reason. Oh, look, it used the QuickSync. Gotcha. So it's using the QuickSync instead of the GPU. Now I see that. Yep, 84 degrees Celsius, 85 degrees Celsius in the GPU. So that's what happened. It dumped the... Wow, interesting. So the section that was hard for it to render, it just rendered on the QuickSync engine. Interesting. All right, it's 12:39. We're 5 minutes in. We're almost done though. It says 11 seconds, 10 seconds. So it's darn close to finishing. At least I think so. It's almost, there it goes. So yeah, I mean, it's over 5 minutes to render that out. So we're not talking a huge difference between the DaVinci Resolve, which was 3 minutes and 33 seconds. I would say this is probably more in the line of 5 minute and 20 seconds or 5 minute and 30 seconds. So it's 2 minutes slower to render on Premiere Pro than DaVinci Resolve, which isn't horrible, I guess, if you are a Premiere user. But imagine if the sequence was a lot longer. Imagine if you were doing these effects everywhere. That's where it really matters. All right, we're going to go ahead and save this and quit it. And I want to take a look at the playback. And I want to show you that the playback is exactly what I said it was going to be. All right, here's our playback from our Premiere Pro sequence. Sorry for the stupid exposure issues. My phone, I have to tap the screen. And you can see it. It is 10.33 megabits a second. And it's 3840 by 2160. So all that's correct. It all looks pretty good to me. That's the way it's supposed to export. Okay, let's look and see. Hold on a second. Close this out really quickly. And all right. Let's go ahead and open the DaVinci Resolve one. Sorry for the focus, guys. I can't use my hands at the same time. All right, so this is the DaVinci Resolve output. So you can see that it is, of course, the same version, same output settings and everything. Hold on, I'm gonna fast forward a little bit. See how it looks. Yeah, see, it renders really nicely. Look at that, the render's perfect. There's no issues with it. People were complaining about how the rendering might have some pixelation or some artifacting on it when I had those motion graphics, but they look totally fine. Our CPU performance in playing back right now is totally normal, 54 degrees Celsius. Oh, dang, focus. 54 degrees Celsius, it's perfect. Let's put the fans back on normal speed so that we don't have to hear that constantly, which you can't hear anyway. And yeah, it plays back perfectly fine. This is as good as it can do, pretty much. You know, it's nice to have a laptop that plays back 4K completely smoothly. Look at that. Nice and smooth. Wow. Yep. It works pretty good, this laptop. I've been very impressed with it for what it is, you know. This is an expensive laptop, but it is also one of the thinnest and lightest weight and most powerful laptops Apple's made and on the market today. I mean, obviously you can get a PC laptop that runs NVIDIA chipset that would be a lot faster, but in terms of CPU performance, this is basically what exists today until a new chip comes out, which I know that the 10th generation chips just came out, but Apple will be using those later in the year. Until that chip is actually used in an Apple laptop, we don't know how much faster it is compared to this. It might be almost the same speed. So I guess that really kind of concludes my test today. I really appreciate you guys watching. I hope you learned something from this. And if you want to buy an Apple laptop, maybe this is a good way to learn about the performance of one before you actually pull the proverbial pin and actually buy one and spend the money. Thanks for watching, and I'll have another video very soon.